So let's look at a big old example of how to do the math part of a limiting reactant problem. Because in exercise 17, we said on this exam, we're not just doing math for math's sake. Sometimes we have to understand the process. That doesn't mean we're not going to have to do math. We will have to do math. So let's look at this problem, limiting reactant problem, where we actually have to do math. But here's it's going to be an example. So first you must realize that you need a plan of attack in the first place. If ever you are faced with two starting amounts of matter reacting, you have entered the land of a limiting reactant. When you're faced with this situation, calculate the number of moles of everything you are given. Calculate the number of moles of everything you are given. Does that sound familiar from our example of setting up our table math? Set up your table like before, only now you'll have two amounts and thus two numbers of moles when you get started. Cover one set of moles up, pretending you only had one amount to work from. And ask yourself, this is a good question, what if all of these moles reacted? How many moles of the other reactant would I need to use up all of these moles? Next, do the calculation of how many moles of the other amounts you would need. Do you have enough? This is the key question here. Do you have that much? If so, that reactant that you begin with is the limiting reactant. If not, repeat this process with the other reactant amount you are given. Now, it doesn't matter which species you start with, right? We just want to play that what-if game. What if all of these moles reacted? That's the what-if game that we're talking about right here. You will get there either way. All right. So still talking about the Haber process that we looked at for exercise 17, so it's nice and familiar. I already have my table set up. Luckily, this is an already balanced chemical equation. We had it from the exercise. There are two nitrogens here, so it has a molar mass of 28.02. H2 is 2.02. And ammonia is 17.03. Again, simply adding up the molar mass will get you that. It just takes a few moments. Now, we already have this balance, so the number of moles for the mole-to-mole ratio is 1 and 3 and 2. So let's suppose that 25.0 kilograms, which is the same as 25,000 grams, that would just be easier because kilograms don't really go in our molar masses very much, reacts with 5 kilograms, so that's 5,000 grams of hydrogen to form ammonia. What mass of ammonia can be produced? All right, so this is the product, right? So we want to know how much of the product can be produced. We also need to know which reactant is the limiting reactant. And lastly, what is the mass of the reactant that is in excess, right? So that is to say, how much is left over, right? So that's after the reaction has taken place. So the problem has given us two masses, 25,000 grams and 5,000 grams. Insert the masses in the amount row and find the number of moles of both. Right, using the molar mass of nitrogen, which is 28.02, I can calculate that 25 grams of nitrogen is 892 moles of nitrogen. My calculator has disappeared, so let me get that booted back up. Sorry for wasting your time here. Let's see, so we know that we have 25,000 grams. We're dividing that by our molar mass. Come up with 892. All right, so we're cool there. All right. 5,000 grams of H2 coming in at 2.02. We have 2,475 moles. Okay. So these are now the numbers that I'm going to use because I know that they're supposed to react at a 1 to 3 ratio. So let's ask the question, what if? What if? What if I used up all the moles of hydrogen? What if I used up all of these moles? Right? If I used up all of these moles, I would need 1/3 the amount of nitrogen. Right? However much this is, I would need 1/3 of it in order to get, I would need 1/3 of this amount of nitrogen to completely react with this amount of hydrogen. So, do I have that much? 3. Do I have this much? Yes, I do. Clearly, I have excess moles of nitrogen, right? I only need 825, but I have this much left over. What is that? 67? I have 67 moles in excess. I can tell immediately right there. Now, if I was going to do this the other way, what if I used up all the moles of nitrogen, right? All the moles of nitrogen, the 892, I would need 3 times as much hydrogen, right? It's a 1 to 3 ratio. So let's see if I can do that. 892 times 3. I would need 2,676. And I do not have that many moles. Right? So clearly I do not have enough hydrogen, so it is limiting me. I don't have enough hydrogen. I have too much nitrogen. I don't have enough hydrogen. So hydrogen is the limiting reactant. Nitrogen is the excess reactant. Either way you go about it, right? If you asked, what if I used all the hydrogen, how much nitrogen would I need? Or if I used all the nitrogen, how much hydrogen would I need? Either way you go about that, you're going to establish that hydrogen is the limiting reactant. So I will modify my table. What do I mean by modify my table? Well, I know that I'm going to use all of the hydrogen because it's limiting. I'm going to use this much. Well, if I'm using this much hydrogen, I can only use 825 moles of nitrogen, right? Because I'm not going to use all of this. There's about 67 moles too much. I'm only going to use this much. So if I want to figure out what the mass that is going to be used here, I'm simply going to multiply the 800, right? So I'm not using the 892. I'm using the 825, multiplying it by the molar mass of nitrogen, right, from up there. And I figure out that I am actually going to use 23,116 grams of nitrogen. Fair enough? So, if I'm going to use this much, how much is in excess, right? Because this is the excess reactant. I use this much. I was given this much, but I'm not going to use all of it. So simple subtraction, right? I have this much. I use this much. The difference is 1,884 grams. So I have 1,884 grams in excess. The other question that is going to be asked very, very regularly is how much ammonia is going to be produced. Well, this is a 3 to 2 ratio, right? A 3 to 2 ratio. And so I am going to use a 3 to 2 mole ratio to figure out that if I were to react all 2,475 moles of hydrogen, which I am, because this is a limiting reactant, it's going to be completely consumed, I could produce at a 3 to 2 ratio 1,650 moles of ammonia, right, of ammonia. Now, the question didn't ask me for a molar value, it asked me for grams, and so I multiply it by the molar mass of ammonia, and I end up producing 28,116 grams of ammonia. So let's visit the question again to clean it up here. Suppose 25.0 kilograms of nitrogen reacts with 5.00 kilograms of hydrogen to form ammonia. you should see that we're using 3 significant figures here. What mass of ammonia is produced? Well, the number that I calculated was 28,116 grams, but that's not 3 significant figures, so I shortened this to either 28,100 grams or 28.1 kilograms. Either is going to work for the AP graders. However, if you had to choose, give your mass in the same unit that the question is given in. The other question, which reactant is the limiting reactant? Hydrogen, right? Once that's established, we discard the nitrogen amounts, and we let hydrogen be our guide. And the last question was, what is the mass of the reactant that is in excess, right? How much is left over? Now, we calculated on our workup here 1,884 grams. Well, that's not 3 significant figures. So the best thing to do, again, it's polite to respond to the unit given. 3 significant figures, 1.88 kilograms or 1,880. A little better. 3 significant figures.